We already found a nice formula for the area of a rectangle inscribed in a circle. It's just 4r squared sine theta times cosine theta. You might also notice that when you're looking at that angle theta, if theta was actually 0, you'd just be talking about a horizontal line. And if theta was pi halves, you're just talking about a vertical line. Those are minimum values because they have no area, so whatever the maximum value is, it has to be somewhere between 0 and pi halves. To find that maximum value, we just need the derivative. Remembering that 4r squared is a constant, we just copy it down into the derivative, and then we use the product rule. The derivative of sine is cosine, and the derivative of cosine is negative sine. Cleaning that up, we get the expression, the derivative is 4r squared times cosine squared minus sine squared, and we just need to set that equal to 0. Which means that we've got cosine squared is sine squared. Said another way, we have tan squared is 1. And there it is, we're done. The critical point is that theta equals pi fourths. But if you listen to the intro video, you'll know, okay, we're not actually done. The goal is to find the area, and we haven't done that. We just said that the area occurs at pi fourths. We haven't said what the area is. But that's pretty easy to do. We just have to plug in theta is pi fourths into our expression for the area. Sine of pi fourths is root 2 over 2. Cosine of pi fourths is also root 2 over 2. If you simplify that expression, you end up with the area is 2r squared, which we'll put in a box because people like to put their answers in a box. Oh, and I see we've got a small grammatical error. If you're doing really well, you'll know we still aren't actually done. What we found was that the critical point occurred at pi fourths, and that gave us a value of 2r squared for the area. We still need to check that it really is a maximum. So let's make a plus minus chart for the derivative. If theta is bigger than pi fourths, then sine is bigger than cosine, and so all told, our derivative is going to be negative. Similarly, if theta is less than pi fourths, cosine is bigger than sine, and so our derivative is going to be positive. That means that we really did find a maximum value. Alternatively, we can simply check every single critical point. The two endpoints that naturally occur, pi fourths where the derivative is 0, and in some cases, not this one, places where the derivative doesn't exist. The maximum value occurs at pi fourths because at the two endpoints the area is 0, and so we have indeed found a max.